Welcome back to another explainer. Today we're setting up a rigorous scientific investigation into the biomechanics of soft tissue pain. We are going to look right past the ancient philosophies and dig straight into the modern anatomical research to understand exactly what is happening under the skin when a needle meets tissue. Okay, let's dive into this. Have you ever wondered why you might have this terrible, aching pain in your shoulder, but a clinician treats a completely different spot way down your arm or on your back, and suddenly, no way, the shoulder pain vanishes? This phenomenon is called referred pain, and it creates a fascinating biological puzzle. We naturally just assume that where it hurts is where the problem is. But as you'll see, the human body's internal architecture has a very different way of distributing tension. So here is our roadmap for today. We'll logically trace this by looking at what is deep fascia, the pathology of pain, how acupuncture mechanically works, grading the scientific evidence, and finally, why target deep fascia. Let's start with step 1. What is deep fascia? It's basically the body's biological fabric. Before we can fix the pain, we really need to understand the anatomy. Think of deep fascia as a biological fabric. But it's not just some static wrapping, it's a dynamic 3-layered system. First, at the structural level, you've got this incredibly strong woven matrix of type 1 collagen and elastin, which gives it both strength and stretch. Second, and this is absolutely crucial, we have the sliding interface. This isn't just empty space. It's a dynamic, fluid-mediated system heavily driven by hyaluronic acid, allowing layers of fascia and muscle to smoothly glide right past one another. And finally, fascial continuity. Deep fascia doesn't just stop at the end of a muscle. It connects into systemic body-wide chains. It's like a giant net. When you pull on one end, the whole net shifts. That is exactly how tension spreads globally through your body. Moving on to part 2, the pathology of pain. Let's look at what goes wrong when that sliding interface breaks down. So what happens when this beautifully synchronized system is subjected to trauma, or even just everyday overuse? Well, it leads to a condition called densification. So the crucial point is that hyaluronic acid we just talked about, normally it acts like a lubricating fluid, but when exposed to injury or lack of movement, its viscosity actually changes. It chemically transforms from a smooth fluid state into a sticky, thick, tangled gel. Imagine pouring syrup onto a table. It completely loses its ability to slide, right? This abnormal thickening is densification, and it causes mechanical stress to build up because your tissues are quite literally sticking together. Now, clinically speaking, we have to contrast densification with fibrosis because they feel totally different during an objective physical exam. Densification feels sticky, almost gel-like to the touch. The patient usually feels an aching, tight sensation, and the great news is that this sliding loss is reversible. Fibrosis, on the other hand, happens when the actual structure of the tissue changes. This presents as hard, clearly defined nodules or cords under the skin. It causes sharp, radiating pain, and because the actual tissue architecture is altered, it's much, much harder to reverse. But here's the thing that ties it all together. Whether you suffer an acute trauma or just repetitive overuse, the tissues follow this exact same pathological chain reaction. It almost always begins with step 1, densification, where you lose that glide. If you leave it untreated, the chronic lack of movement leads to step 2, fibrosis and adhesion, where the tissues actually stick together. And that eventually triggers step 3, retraction and shortening, where the body just adopts a compensatory posture, adapting to the tension by shortening the fascia and muscle fibers. And this perfectly illustrates our opening hook. Because of those continuous systemic chains in the fascia, tension transmits far away from the initial site of densification. The pain location literally does not equal the lesion location. That spot where you feel the aching pain, it's often just an area of high stress, while the real problem, the actual sticky, densified root cause, is hidden much further up the mechanical chain. All right, let's jump to section 3, how acupuncture mechanically works. We're zooming in on the needle interface. Shedding all those traditional philosophical interpretations, let's just look at the pure biomechanical facts. To actually affect the deep fascia, you need a highly specific clinical technique. The practitioner has to first target the exact depth of the deep fascial layer. Once they're there, they apply a unidirectional rotation, basically twisting the needle continuously in one direction for 180 to 360 degrees. After that rotation, they apply a downward axial pull, pressing the needle down just a bit. Finally, they leave it in place to maintain continuous mechanical tension. Listen, depth and angle are absolutely critical here. If you're too shallow in the skin or too deep in the muscle belly, this specific mechanical reaction just won't happen. So why the twisting? It's all because of a phenomenon called winding. I want you to imagine twirling a fork in a big plate of spaghetti. As you spin the fork, the noodles physically wrap around the tines, pulling the surrounding noodles tighter and tighter, right? That is exactly what happens with the needle and your collagen fibers, and we can actually see this in modern ultrasound research. The rotation creates a direct, undeniable mechanical coupling between the metal and your biological fabric. If you've ever had this done, you might have felt that deep, pulling, heavy ache, which is often called needle grasp. Now, some folks mistakenly think the needle is just awkwardly stuck, but the science shows us that needle grasp is not an error. It's the collagen fibers physically winding around the metal. Because of this physical grip, the pushing and pulling forces applied to the needle radiate outward through those fascial continuous chains. And that explains exactly why the aching sensation spreads outward rather than just stinging right at the point of the needle. Let's move to section 4, grading the scientific evidence. It's time to separate the hard facts from unproven theory. Now, what's really interesting about this slide is how we can draw strict boundaries on what science has actually proven. If we look at the level of tissue mechanics, Dr. Helene Longine's 2001 ultrasound studies on needle winding provide solid, undisputed evidence that this mechanical coupling really happens. Moving down to cellular response, Dr. Robert Schlape's 2006 research gives us solid evidence that specific cells in the fascia, called myofibroblasts, actively contract in response to mechanical stimulation. However, when we get to clinical cure, the idea that this specific mechanism alone triggers complete disease healing through the central nervous system, well, the evidence status there is unproven and incomplete. It's an ongoing hypothesis for sure, but the strict causal chain hasn't been definitively proven just yet. We have to vigorously separate the proven science from pseudoscientific claims here. It is a proven fact that myofibroblasts exhibit an autonomous cellular response to stretching, entirely independent of the nervous system. Mechanical stimulation objectively triggers these cellular signals. What is absolutely not scientifically supported are claims that fascia has some kind of independent panpsychic consciousness. And those old Galvani-style experiments where an animal muscles twitched after death, that just proves electrical excitation in nerves and muscles. It definitely doesn't prove that fascia possesses mystical energy. The real, undeniable marvel here is just the objective cellular mechanics. Which brings us to our final section, Part 5, Why Target Deep Fascia? Why is it the ultimate therapeutic target? With all the layers of skin, fat, and muscle in the body, why is this specific biological fabric the key to the whole puzzle? Let's summarize. Deep fascia is the ultimate target because it uniquely contains the continuous fascial chains that explain how tension travels across the body. It houses that vulnerable hyaluronic sliding interface, the exact place where densification and that sticky gel problem begin. It contains those autonomous, contracting myofibroblasts that respond directly to a mechanical pull. And finally, unlike a generalized massage, it can be mathematically targeted. By controlling the exact depth, angle, and rotation of a needle, a practitioner can completely bypass the skin and muscle to directly manipulate this exact anatomical layer. So I want to leave you with this provocative question. If a patient comes in complaining of shoulder pain, and we now know that this pain might literally just be an echo of mechanical tension traveling up a fascial chain from a completely different densified area, it forces a massive shift in perspective. Are the treatments you rely on actually unwinding the sticky biological root cause, or are they just chasing the symptom? Understanding the biomechanics of soft tissue isn't just an academic theory, it completely changes how we view healing. Thanks for joining me on this explainer, and keep asking the right questions.